All right, this is a video for day one of the RATEY graphing rational functions. And RATEY comes from the acronym SRATEY on your green sheet. And so we'll be talking about each of those letters and what this information means while we go through the lesson. And before we actually talk about the lesson, I want to show you, in the last class we did an exploration activity where you just graphed these functions either in Desmos or a graphing calculator and then sketched them. And there's a few patterns I want to point out that we're going to rely on while we graph today. So for example, if you look at number 4, notice that this graph has 3 parts, and I want to draw your attention to these end pieces right here and how they have this curved L shape, right? So for today's lesson, every end piece that we have on our graphs will have this curved L shape. And there's 4 different places that could be. It could be like this one here, this one here. We might have some graphs where that L shape is here or here. But the end pieces, the ends will have this basic shape rotated one of 4 different ways. And then this graph right here has 3 pieces. So when you have 3 pieces, the ends are going to be curved L shapes. The middle piece is either going to look like this sort of snake piece. It looks like x cubed that's been reflected. So the middle pieces will look either like x cubed if it passes through its x-intercept, or if you look at this problem, if that middle piece bounces off of its root, is tangent at its root, then it will look like x squared. So what I want you to keep in mind as we're trying to draw our graphs today by hand is that the end pieces will look like an L shape, and the middle pieces will either look like x squared or x cubed in some way. Now some of the graphs will just have 2 pieces, and if it's got no middle piece, then just think of it as having 2 ends, 2 end pieces. So both pieces will look like the L shape somehow. All right, so keep that in mind as we are going over the shapes for this lesson. So the best thing you can do while going over this video is to have both your green sheet nearby and the notes that you're working on, because I'll be referring to the green sheet the whole way through. So the point of this acronym is to gather information about the important parts of the graph that we can use to sketch the larger picture together. So starting with R, the R stands for roots, and on your green sheet it says that's the solution to the top. It's the numerator. So just take your numerator, set it equal to 0, and solve it. So x equals -3, and then this is a point in ordered pair, so I'm going to write it like that. X is -3 when y is 0. I'm going to put that on my graph here. Then A stands for asymptotes, specifically vertical asymptotes. The denominator cannot equal 0, so that creates a vertical asymptote there. Set it equal to 0 like we did the numerator, and solve. And in this case, we can leave it as x equals -5 because that is the graph of a line, which our asymptote is a line. So I'm going to go ahead and graph that here. And it's going to be a dashed line to show it's not, a solid line would actually be part of the graph. This is not part of the graph, but it does determine the behavior of the graph. So remember, an asymptote, the graph cannot cross it, but it will approach it. Now T is not going to give us an actual point on my graph. It's more like the behavior at certain parts of the graph. And if you look at your green sheet, it says tangent over together. It's written like a fraction. Tangent is referring to the behavior of the roots. Is the graph going to cross through or bounce, be tangent? And together is about the behavior at the asymptotes. Is it going to be going the same direction on either side of the asymptote, or is it going to be going in opposite directions? So going the same direction would mean coming together, and going opposite directions would not be coming together. And the way that you can tell if this is going to be the case is whether or not your factored forms are squared or not. So in this case, we're looking at is x plus 3 squared, and it's not, so I have none, no squared factors. And here it's also not squared, so I have none. And we'll explain this more as we get into problems where there is stuff squared. So E stands for end behavior. So there's 3 options for end behavior. Today we're only focusing on the first or the last one. We'll talk about oblique in a different lesson. So today we either have a balanced situation or a bottom heavy, and the way you can tell is this. You look at the leading terms. So my leading terms here are just x over x. And looking at their exponents are the same. So we would call this a balanced situation. And here's what you're going to do with that information. Simplify the leading term ratio that you set up. That simplifies to 1, because anything divided by itself is 1. So that value is going to be your horizontal asymptote. So I'm going to draw that in right now. And then y stands for y-intercept. That's where your graph is going to cross the y-axis. And everywhere on this line, x is 0, which means you can literally just plug 0 in for the x's here and then simplify. Right, so this gives me the point 0, 3 fifths. So I'm going to graph that here. All right, so now because we have one vertical asymptote, we're only going to have 2 parts to our graph. We're going to have the part that's on the right of the asymptote and the part that's on the left. And we talked about how that's going to be your basic curved shape. And that can go in one of 4 directions. Right? It can go this way, this way, this way, or this way. And we have enough information here to tell that, and this portion of the graph where we have 2 points already graphed on here, that we're going to have this basic L shape that goes through those 2. It's going to be kind of not the prettiest, but you get the drift. Oh, definitely not pretty. Okay. So there's my basic L shape that goes through those 2 points. And now all we have to decide is on this side of the line, is my L shape going to be like this, or is it going to be like this? So remember, the asymptotes divide this up into different quadrants, and the behavior of the graph can approach it but not cross it. And the way we can decide which of these we need is this T step right here. So the bottom information is telling me the behavior at my vertical asymptotes. The top information tells me the behavior at the roots. So if my factor here was squared, that would mean the behavior is coming together at either part of the asymptote. It's going to be going the same direction on either side. But we weren't squared, so it's not going to be coming together, it's going to be going apart. So if it is down, if it's going to negative infinity on the right of the asymptote, it's going to be going to positive infinity on the left. They are going in different directions, and so that's how I know this is the L shape that I need for the second part of my graph. And I don't need this. All right, so there's my basic shape right there. Now in number 2, there's an example of, well, what happens when you do have something squared for the asymptote? So let's work that one. So R stands for roots. You set your top factors equal to 0 from the numerator. So that's x plus 1 equals 0, x minus 6 equals 0. Solve them. And these are ordered pairs, so I'm not going to leave them in this form. I'm going to write them as points and put them on my graph. A is setting the denominator equal to 0. Now, x minus 2 parentheses squared means x minus 2 times itself. Now, I don't need to set both of those equal to 0 and solve. They're the same. So I'm just going to do one. X minus 2 equals 0, so x equals 2 is the equation of my asymptote. T is for tangent over together. Are either of my factors in the numerator squared, meaning if they were squared, it would look like that. Okay, but they are not. So I'm going to say none are squared in the numerator. None being squared means that at these roots, the graph is not tangent. Tangent is a bounce. It would come towards it and bounce off. If it's not tangent, it's going to come towards it and cross through. That's what that means. And then the denominator factor is squared. So yes, we do have something squared. So what that means is the graph is going to come together at that asymptote at x equals 2. Now I can't graph that yet. This information is just going to hang out, and I'm going to use it later when it's time to sketch my pieces. So this is just going to hang out here. And then E for end behavior. So we have to do some math, a little bit of math here to figure out what our leading terms are. Imagine for a second, so first I should say, your leading terms come from your standard form, but everything here is factored form. So I would get standard form in the numerator by foiling. X squared plus 1x minus 6x minus 6. Now we don't have to go through the entire process when I only need the first term. So I'm just going to do the first terms only. That would give me x squared in my numerator. And same thing on the bottom, x minus 2 times itself. I'm only interested in what would the first term be, and it would be x times x, or x squared. And this is a balanced situation. The exponents are equal. So in that case, you just simplify it. That's going to give me 1. And so my horizontal asymptote is y equals 1 again. And then y-intercept, I'm going to plug 0 everywhere I see an x. Order of operations says to do parentheses first. Now my exponents and multiplying, so negative 6 over positive 4 is a negative 3/2. So I have a y-intercept at 0, negative 3/2. So that's 0, negative 1.5, which is about right here. And now that I have 2 points in this quadrant, that's enough information to graph my L curve. Since I only have one asymptote, I only have 2 pieces. They're both going to behave like end pieces, which means they're going to have this basic shape right here. And since I already have these 2 points, I'm just going to draw in my L shape there. And then to decide on the right-hand side, my L shape could either go here or here. So to decide which way I need, I'm going to use my T information. So we said that because this factor is squared, that the graph is going to come together at x equals 2. So together means the same direction on the left and right side. So on the left side of this asymptote, it's going down. So coming together would mean on the right side, it also has to be going down in the same direction. So it's coming like this. They're coming together. Thank you. So they're coming together like this. That's together. And so I know I need